Hi everyone, today we are discussing parallel and perpendicular lines. We know that parallel lines have the same slope. They have the same slope because there's the same amount of space between these lines. Okay, so if the first line up here had a slope of 5, then that means the second slope would also have a slope of 5. Okay, they would not be horizontal. Of course, they would be at an angle. All right, we also have perpendicular. Now, perpendicular slopes look like a T, okay? And they form a right angle. So when we need to do perpendicular slopes, we find the negative reciprocal slope, meaning that we flip and change the sign. Okay, so if the first line had a slope of 2/3, then I would flip the fraction upside down and change the sign from positive to negative to find a line perpendicular. So the perpendicular line would have a slope of -3/2. Okay, so one of the things that we need to remember here is that if we have a whole number for our slope, such as what if we had a slope of 2? Okay, so let's say we had a slope equal to 2, then parallel would be a slope of 2, but perpendicular would be a -1/2 because 2 flipped upside down has to form a fraction. Okay, so 2 is really 2/1. All right, this note right here is very important. It says that slope of 0 and slope of undefined are perpendicular of each other. Okay, now slope of 0 is a horizontal line like this. So this is slope of 0, and then vertical line like this. Slope is undefined. Okay, so we have parallel, perpendicular. Okay, parallel has the same slope, perpendicular, negative reciprocal, flip and change. Okay, undefined slope is up and down, slope of 0, remember, is horizontal. Okay, so steps to determine parallel and perpendicular lines. First, we have to find the slope of the lines that we're working with. So it could be we're using a graph, it could be by formula, it could be by equation. Okay. If they're asking about parallel lines, then those lines should have the exact same slope. And if they are talking about perpendicular lines, then we have to flip the fraction and change sign. In other words, we're finding the negative reciprocal. So let's go down and work a couple problems. So these are our examples that we're going to work here. And here we have 2 points. And it just wants us to find the slope. So remember, you have a couple different ways that you could do slope. You could do slope formula, vertical. Okay, I'm going to do the vertical formula here. So we just subtract -3 minus a -5 is +5, so that's 2. 5 minus a -8 is 5 plus 8, which happens to be 13. And then we do rise over the run. So that's 13 divided by 2. Okay, So the slope of this line that contains these points is 13 over 2. If I have a parallel line, then that would be the same slope of 13 over 2. The perpendicular line to this line would then be negative 2 over 13. Okay, so find the slope. Parallel is the same, perpendicular, flip fraction, change the sign. Okay, example number 2 over here. This time we're given an equation. So we need to solve for y equals mx plus b so that we can pull off the slope. So we're going to come down here to do our solving. Y is on the left, so we can leave everything alone. We need to add 5x to both sides. That gives me 3y is equal to positive 5x plus 9. And when I divide by 3, I have y is equal to 5/3 x plus, and 9 divided by 3 is 3. So the slope, remember the slope is sitting right there in front of the x, is just the fraction 5/3. So a line that's parallel to this line would also have a slope of 5/3. And a line perpendicular to this line would have a slope of negative 3/5. Okay, so to show you an example, if I wrote y equals 5/3 x plus 3, and then I gave you another line that said y equals negative 3/5 x minus 1, if you look at the slope, 5/3, negative 3/5, okay, they're not the same, so these lines would not be parallel. So then I have to check perpendicular. Does it look like the second line, the fraction flipped upside down? Yes. Does it look like it changed sign? The first one was positive, the second one is negative. Okay, so this right here is an example of perpendicular when you see an equation. Okay, so in the black, that's what we solved for. In the purple and the red, this is an additional line to show you what perpendicular slope looks like in an equation. Okay, so you look at one, you compare the two slopes. If they're the same, they're parallel. If one looks like it's flipped upside down with a sign change, then they're perpendicular. Okay, so that leads us to number 3, which says, are these lines parallel, perpendicular, or neither? So for each line, we need to kind of figure this out. We want to just really solve for y here. So we're going to take and solve for y. So we have negative 3y minus 9x equals 4. So if I add 9x, whoops, we have negative 3y is equal to 9x plus 4. When I divide by negative 3's, okay, I divide through by negative 3. So I have y is equal to a negative 3x minus 4/3. Okay, and now I'm going to take the second one and I'm going to do that one in blue, and we're going to solve it. So we have 30 plus 15y is equal to 5x. We will subtract 30 from both sides. That gives me 15y is equal to 5x minus 30. And then divide by 15. So y is equal to, now 5 divided by 15 is 1/3, because 5 goes into 15 three times. So 1/3 x, and 30 divided by 15 is 2, so minus 2. Okay, so what I want to do is I want to compare these slopes, just like I did on the second part of number 2. This one is -3, and this one is positive 1/3. Okay, so if I look at these two lines, one, they are not the same number, so they're not parallel. Okay, are they perpendicular? Well, -3 turned upside down is -1/3, and then I change the sign, I get positive 1/3. Okay, so these in fact are perpendicular. Okay, if none of these would apply, then they would be neither. Okay, so here's another way that you can look at it. If I took line A, which is this one, the slope of that line is -3. So the second line, if I was asking for parallel, should have a -3. And when I look, does this have -3? No. So it's not parallel. So I come back and say, okay, well, this line perpendicular should be positive 1/3. And I look here and say, is this positive 1/3? Yes. So you're just comparing. So that's two different ways that you can decide if lines are parallel or perpendicular. Okay. Here we're just going with a graph. So you could take the coordinates and do like we did in number 1, or you could come here and just count up and over to figure out your slope with the rise and the run, which is what I'm going to do. So I'm going to say that my rise over run, so I rise up 1, 2, 3, and then I turn to the left. When I turn to the left, now I'm going in the negative numbers, 1, 2. So my rise is 3 and my run is -2. So this slope is -3/2, meaning a line that was parallel would have that same slope. And a line perpendicular, flip it upside down. And this time we went from negative to positive. Okay, so that is parallel and perpendicular lines.